Thanks again to Mike for that introduction, and thanks to everyone for joining us this morning virtually. And on behalf of the organizing committee of this workshop, welcome. So if you're hoping to be at the SDL workshop, you're at the right place. We'll just use SDL from here on out. So this will take place over the next 3 days, 10 a.m. to 3 p.m. We tried to keep it kind of condensed so you don't have these long 8-hour days as we've had in some other workshops. We found that to be kind of exhausting in the virtual format. So it'll be 10 a.m. to 3 p.m. Central Time. We really wanted to make sure that everything was hands-on and engaging, and you could return to these hands-on exercises as you take the lessons you've learned in the next 3 days and apply them back to your own scientific projects. So the workshop will focus largely on scientific machine learning and data science at HPC scale, and with an especial focus on preparing for applying for an allocation of your own on ALCF machines about the next year. And these successful proposals describe, an end-to-end workflow where everything's optimized and running quite well and using our resources with high efficiency. And so we cover things from scaling out your AI or data science workloads and profiling them on single nodes so that everything runs well, in addition to integrating them with existing simulation-based codes. And please feel free to, at any time, have this on in the background and listen as the tutorial leads take you through the hands-on. Take your coffee breaks whenever. We'll have a scheduled break each day, I think at 12:30, but in between or even during the tutorials, definitely feel free to recharge and grab coffee as needed. Keep your video and mics off and coordinate through Slack as the Slack or the Zoom chat is disabled throughout the workshop. So as I mentioned, Slack is the #1 way to get help as we go through the hands-on exercises. So all the speakers and additional ALCF staff should be available in the Slack workspace, which is at this URL. These slides will be posted there as soon as I'm done presenting this. And this should be a resource you can return to if you ever get stuck or don't know where to turn to for help or how to run certain commands. I'll preview in a second. We even have specific public channels that are in a one-to-one correspondence with the GitHub repository I posted earlier. There are folders in there that are labeled similarly, which correspond to the hands-on exercises. So if you get stuck during the data pipelines tutorial, for example, I would start a thread in there, get the discussion flowing. The speaker and helpers should reply to your thread there. If you have any problems getting on to Theta or Theta GPU, or having other SSH problems or whatever related to even just getting started, post in the help desk channel and someone on the support team can make sure your account credentials get sorted. And be sure to follow the announcements and general channels for any workshop updates. There's always something that pops up with our allocation or our accounts that are changing the schedule, and we'll post announcements there. But a big part of this workshop is getting one-on-one help with your own codes, not just the hands-on tutorials that are walked through during these tutorials. So if you come up with a question that is relevant from the tutorials or whatever that is relevant to your own scientific code or whatever problem you happen to be working on in your own research, reach out to a speaker that you think could help you or ask for suggestions, and you can go into direct messages for more one-on-one help, or you can even use the video or audio call features, share your screen with an ALCF expert to really accelerate your progress. And get ready for a director's discretionary allocation or any of the other allocation programs, which is, again, a big focus of this workshop. And so here's a list of various allocation programs that the ALCF offers that you can apply for. Of particular note are the ALCF data science program allocation. So the applications for that will be due in, I think, 5 months or so. So unlike last year, we held this workshop in December and you had a month or two to prepare. You should have a bit more lead time after this workshop to generate ideas and gather your scaling results, your efficiency results to put together a compelling ADSP proposal. But on a smaller one, you can also get director's discretionary allocation, which we can talk about on day 3 and after the workshop, which can be a lead up to a larger allocation application. So the machines that you'd be interested in targeting right now are Theta, which is consists of basically 2 machines, which I'll get into in a second, which we'll be running on today. Polaris, which is getting delivered right now, which is a much larger machine, but shares a lot in common with the Theta GPU machine. And Aurora, which is the exascale machine, which should be delivered next year. That'll be a longer term allocation. And the idea is you can start by getting efficiency results on Theta GPU, which should inform a lot about how your code or codes might run on Polaris, which in turn has some similarities with Aurora, and you can ramp up to really doing HPC scale data science, machine learning, simulation codes. Here are links, useful links for just generic documentation that you can always revisit if you get stuck during the workshop. So Theta KNL and Theta GPU are the only machines we'll actually be using for the hands-on for the next 3 days. As mentioned, Polaris is in the process of getting delivered, but you can get some information about it here. We'll also be previewing the AI testbed platform, which has a couple of startups which have been developing specific hardware for machine learning. We'll get a preview about that. It's not open for allocations right now, but may become open in the future. So Cobalt is the job scheduler used for Theta KNL and Theta GPU. You'll primarily interact with it through the QSub command. In particular, we need to specify the queues and the allocation program for all your QSub commands. As mentioned, we'll be using Theta KNL and Theta GPU throughout the workshop. Here's just a reference slide for the Theta KNL architecture. There's a lot of details here, but the key thing to note is just that a single node consists of a single Intel KNL socket. So it's a completely different architecture than the Theta GPU partition, which is NVIDIA based and has 8 A100s per node. So because they're completely different architectures, the software environment is completely different. The number one problem when doing tutorials that engage both machines, even though they share the same name, have completely different software environments. And so people often run into problems where they'll be doing part of the tutorial on Theta GPU using a command that only works for Theta KNL. So here is another cheat sheet, which can be quite complicated. It shows you the various types of nodes that are involved in the overall Theta machine. So whenever you first have to log into Theta KNL login nodes using your crypto card, and I'll just say Theta login X. And then from there, you can submit a job to Theta KNL or Theta GPU. For Theta KNL, you first use QSub, which gets you onto a mom node, which from there, you'll be able to do app run commands, which actually run your program on a compute node. So the hands-on tutorials should give you kind of the exact or very nearly the exact QSub and app run commands you'll need to run the tutorials. But just be aware that there's 3 different types of nodes basically to get to Theta KNL compute. And similarly for Theta GPU compute, you have to jump through another hoop to go onto a service node, which you don't need to then run an app run anymore. You just do MPI run. The takeaway is hostname is your friend during this tutorial. So when you run into problems with one of the hands-on, first run the hostname command. See if it says Theta login, Theta GPU SN, Theta GPU blank, which is a compute node, Theta mom, or a different or another compute node, and post that when you're trying to get help in the channels, and just always go back to running hostname. Both Theta KNL and Theta GPU have a module system, so if you're familiar with that, here's a list of commands that can help you load your TensorFlow, your PyTorch, your MPI library or compiler version. I'll just note that they're somewhat different systems. One's an environment module, the other one's LMOD, which is a different way of managing these. But they're completely different modules themselves, because of course, one depends on the CUDA libraries and the other one depends on Intel dependencies. So here's the overview of the next 3 days. We're already halfway through the speakers on day 1. We'll hear about distributed data, deep learning with Weho and Corey for the majority of the day. And we'll finish up with Taylor going through building data pipelines. On day 2, we'll largely discuss DeepHyper, which is a software tool developed at the lab, which can do hyperparameter search in a distributed fashion for your machine learning encodes, and can do some new preview features as well will be covered on day 3. We'll also discuss profiling your single node and distributed AI workloads in the afternoon. So here are the faces you can associate with the speakers, and you can ping them on Slack in those channels I mentioned before, or anyone else for that matter, in addition to some other helpers who aren't speakers. And on day 3, we'll finish up by talking about integrating your AI codes with your simulation codes. We'll discuss the preview features as mentioned with DeepHyper. We'll talk about the AI testbed machines that are installed and will hopefully become available to outside users at some point, and applying for allocation programs in the next steps after this workshop. So again, reach out if you have any questions or problems, technical difficulties. Do not be shy. The nature of this workshop is to be very hands-on and engaging, and we hope it is. And if you come across any problems in the GitHub repository, you can pull up an issue there as well. Sorry about those technical issues. I'll post these slides right now. If we don't have any questions, we can get started early with our first hands-on.